Good morning, class. We are entering the end of chapter 5, which again is a review of pre-algebra, algebra, and a couple other things. Today we're going to discuss arithmetic and geometric sequences. And I'm not sure if it's pronounced arithmetic or arithmetic. I don't think it's arithmetic, but it's sequencing. And I know some of you guys are like, oh, I just want to watch the first 30 seconds and see what we're doing. Well, guess what we're doing? We're doing formulas, folks. We're doing formulas. People have gone before us, have discovered, figured out the best methods to solve out these sequences. It's amazing stuff. So just take a screenshot of this. If you're like, I just want to get to the homework, this is the general gist of the lesson. So I'm going to go through each of these specifically. But you can see we're talking about how many terms we have, the difference between the terms, and we're going to calculate out the different pieces. I also linked this into the homework. So this shot here is in the homework as well. It will help save you a lot of hunting and pecking. But at the same time, you're going to want to still understand how this all works. So let's define what is we're talking about. A sequence is a list of numbers that are related to each other by some kind of a rule. Here's one example: 1, 5, 9, 13, 17. The numbers that form the sequence are called terms. So here are the first 5 terms of the sequence. And we would call this first term T1, which is 1, and second term T2, which is 5, etc., etc. Well, in looking at arithmetic or arithmetic sequences, a sequence where each term after the first term differs from the preceding term by a constant amount, we call this an arithmetic or arithmetic sequence. The amount by which each pair is different is called the common difference. The letter D signifies a common difference. And we look here, we have 1, 5, 9, 13, 17. Take a second, think about that. 1, -1, -3, -5, -7. What is the common difference for the first sequence? Oh, it's D is 5, because look at that. D is 4. If I add 4 to 1, I get 5. If I add 4 to 5, I get 9. If I add 4 to 9, I get 13, etc. On the bottom, what is our common difference? Well, the common difference there is going to be -2. If I take 1 minus 2, I get -1. If I take -1 minus 2, I get -3, etc., etc. So some of your homework is going to ask you to find the first terms of a sequence. In this example here, term 3 and the common difference is 5. So the first term is 3 and the common difference is 5. We just start off with 3 plus 5 is 8, plus 5 is 13, plus 5 is 18, etc., etc. First term is 1. Common difference is -1/3. Again, this is for arithmetic. We start off with 1. Plus -1 is 2/3. Plus -1 is, or -1/3 is 1/3. Plus -1/3 is 0, etc., etc. Okay. Finding terms, super useful content. Here is that formula again from the first slide. And we're going to use this formula to calculate out some things. So if we've got 3, -3, 9, and then the rest of the sequence, and we want to find the 7th term in the sequence, A7, we then plug and chug. So if A1 is 3 and D is -6 and N is going to be 7, we can do a little plug and chug. So this is the general formula. And when we punch in N as a 7, we get 3 plus -6N plus 6. And we can calculate that all the way down to this sequence. A7, the 7th term in the sequence, is -6 times 7 plus 9. As you can see, there's a fair amount of work here to get our solution. So as you're doing your homework, please do take the time to write the workout, write it out neatly so that I can understand that you understand how to use these formulas. Find A100 for the sequence 2, 5, 8, 11, 14. Yo! The lucky thing is we've got our formula here. So AN is equal to the first number in the sequence, which is 2, plus N minus 1, we're going to leave that for now, times the difference, the D. D here is, we can figure it out, 3. If I add 3 to 2, I get 5. If I add 3 to 5, I get 8, etc. So then we calculate and solve that down to our simplest form. And now we can solve for N. AN is 100. Well, 3 times 100 minus 1 is going to give us 299. So the nth term, or the 100th term in this case, is 299. Another example, find the nth term for 1, 6, 11, 16. Well, first things first, we're going to find the first term, which is 1, and we have to find the difference between those terms, which is 5. That's right. So 1 plus n minus 1 times 5. Solve that down. Use the distributive property. Remember, we just talked about that. So we have 1 plus 5n minus 4. Solve that down to 5n minus 4. And now we can plug in the n. Well, what's the n going to be? It's going to be any number. So we've already solved it down to the point where we can put whatever number in and find that term for the sequence. All right, next formula. Formula number 2. The sum of the first n terms of an arithmetic sequence. So not only are we able to figure out all the terms, or the nth term, but we can then find the sum of those terms. So let's say we have a starting number 1, and we're going to end with the 25th, and we want to add these up. So 1 plus 2 plus 3 plus 4 plus blah, 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 all the way to 25. We have a formula to help us calculate that out. So the sum of the nth term is going to be the n, which is 25, because we're doing the 25th term, nth term, times term number 1, which is 1, plus whatever the 25th term is, which in this case is 25, divided by 2. We solve this out. Sum of the first n terms in this sequence is going to be 25 times 1 plus 25, which is 26. We divide that by 2. We get 325. So this is a way to use arithmetic sequencing to sum all the terms from a certain sequence. Here's another example. Find the sum. You will have homework problems like this. They will typically give you n because they want to know which term you're ending with. And usually they give you the last one. You might have to figure it out. Some of them are a little double dip where you have to figure out what the nth term actually is. That's where you would just go back and use the other problem, or I'm sorry, the other formula. But we start with 3/5, and then 4/5, and then 1, and then 6/5. And so by looking at this, we can calculate out a difference of 3/5. That is our A1 3/5. That's our first value. And then the nth term is 4, and they give you the 4 here. And we want to find the 18th term, which is n. So in doing so, once we figure out the formula, we can do what I grew up calling a plug and chug. We figure out what this is. Well, first we have to convert 4 into something over fifths because we want to get the same denominator. Well, that's going to be 20 over 5. We add those together. We get 23/5 times our n value out in front, which is 18. And when we do this math here, 18 times 23 is 414 over 5. Well, we can reconvert this into 414/5 times 1/2. That's kind of what this says here. And when we calculate that out, we're going to wind up with 207 over 5, which then summarizes as 41.1. So that is our arithmetic sequences, and that is half our little formulas. Well, we got a couple left, so we got a couple more formulas left, and they look at the geometric sequences. Now, arithmetic sequences is basic addition, so if I go from one term to the next term to the next term, I'm just adding a particular amount. In geometric sequences, we are doing another piece. It's kind of more like a multiplicative piece. So in geometric sequencing, is one in which the ratio of any term and the term that directly precedes it is constant, so the ratio. So on the example down here in sequence 2, 4, 8, 16, 32, we take the previous number and we multiply it by 2 to get the next number. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, etc. So the common ratio, and we use the letter R for ratio, is 2. Second example there, we have negative 48, 24, negative 12, 6, negative 3. In this example, the ratio is dividing by negative 2. So our common ratio, the R, is going to be negative 1/2 because that is what a ratio is, and that is what division is. It's actually multiplying by the reciprocal. So that way we can always be doing multiplication. All right, let's see a couple examples of this. First 5 terms. Here's a series, and the ratio is 4. So I'm going to start with A1, which is the number 3, and then I just multiply by 4. So 3 times 4 is 12. 12 times 4 is 48. 48 times 4 is 192. 192 times 4 is 768. Bada boom, bada bing. However, we also need to be able to multiply by fractions. So if I have 3 as my starting sequence, my starting number, I multiply 3 by a half, then I multiply 3 halves by a half, and I multiply 3/4 by a half, I multiply 3/8 by a half, etc. That's the first 5 terms. You'll have a couple problems like this. Please do show your work. Show how you're getting the solution. The other formula, the final formula, nope, I take it back, not the final formula. This is the formula to find the general or nth term of a geometric sequence. And I have this on that initial slide. I also have it linked in Classroom. If we have an nth term, to find it, we need to know the first term, and we multiply it by r to the nth term minus 1. So to find a7, a1 is -3 and r is -2. We can basically plug in these numbers. A nth value is -3, which is our a1, our first term, times -2, which is the r value, to the power of n minus 1. As we solve this down, we can plug in our 7 here, and now we get 3 times -2 times, or -2 to the power of n minus 1, which is 6. So that's -3 times, remember the parentheses here, very important, -2 times -2 times -2, -2 times -2 times -2, 64. And it finishes out with 192. Now, I think there's a miscue here. This should be, I think, a -192. My bad. Yep, my bad. All right, find the nth term for the sequence 2, 6, 18, 54. So in this, we use our good old-fashioned formula again. First term is 2. The ratio is 3. So a to the n, or a the nth term, is 2 times 3 to the power of n minus 1. And that is the general for these sequences. So some of them you'll just need to find the nth term and calculate out for the nth term of the sequence. Woo! One more formula to go. One more. The sum of a geometric sequence. The sum of a geometric sequence. This formula is amazing. Remember, our ratio cannot be equal to 1, because when a ratio is 1, if you multiply by 1, there's no change. And so we find the sum of the first 5 terms of the sequence, whose first term is 4 and whose common ratio is 2, using this equation. We've got to pull our words out here. Sum of the first 5 terms of the sequence, whose first term is 4 and whose common ratio is 2. So when we talk about the n value here, n is going to be 5. We're looking at the first 5 terms. A1 is 4. That's the first term. A1 is 4. And then our ratio value is 2. So you can see we plug in A1, which is 4. We plug in R2, and we plug in the n value of 5. We're looking at the first 5 terms. So maybe in your notes, if you want to like dissect this a little bit, you're welcome to. When we calculate it out, we get 4 times 1 minus 32, because 2 to the 5th is minus 32, over -1. We solve this. 4 times -31 over -1. We're going to get a sum of this geometric sequence as being 124. So 4 amazing formulas. I wish I would have dropped that slide in here one more time. However, it is on Classroom, and you can check it out, or go back to the beginning of the video and check it out there. Here is your homework for this. Each of these is a couple examples of using the arithmetic and the geometric sequencing formulas. Best of luck. Let me know if you need any help, and I will see you in class.